welcome to CEC lectures. Myself Dr. Priti Jagwani from Department of Computer Science, Aribet College, University of Delhi. So after finishing the topic of sliding window protocols, in which we have looked into stop and wait, go back and selective repeat, today's topic is about MAC addressing. So, MAC, when we say it is, you all are aware that this is media access control, and this MAC addressing or the concept of MAC layer holds a special importance when we read this data link layer, because this is one of the sub layers of the data link layer. So, you all are aware that this data link layer is divided into two sub layers. One is LLC layer, another one is the MAC address. So, here MAC address layer we can say. So, in this lecture we are going to look into both the sub layers in detail. So, when we talk about MAC address, which is media access control address, it is actually the physical address that works at the data link layer of this OSI model. And a MAC address, how are we going to represent, or how long is this MAC address? This is, we can say it 48 or a 64-bit address which is associated with the network adapter. These MAC addresses are linked to the hardware of the network adapter, and they are also known as hardware addresses or physical addresses. So, the basic idea behind this MAC addresses is they are used to uniquely identify the adapter, or we can say they are used to uniquely identify the computer on the local area network. And MAC addresses, if we look into the format of the MAC addresses, they are expressed in hexadecimal notation. So, for example, let us take an example of a MAC address. It is 01 dash 23-45-67-89 AB. So, when we talk about AB, so this is kind of an hexa, obviously. So, the address here is a hexadecimal notation. So, for example, this 01 23 45 67 89 AB in a 48-bit address, this can be also represented in a 64-bit address as 01 24 45 67 89 AB C D D F. So, that is a 64-bit address, and the previous one which is stopping at AB, that is a 48-bit address. So, your MAC address can be a 48-bit address or a 64-bit address, in which we can say the numbers or the pairs of the numbers, couple of numbers are separated by colons. Sometimes they can be separated by colons, or they can be separated by dash, as we have seen in this examples. So, these are kind of, in most of the cases we can say they are permanent, but in some rare conditions they can be changed. So, I am just going to ignore those rare conditions. So, as of now I am assuming that these MAC addresses are permanent. Then if we look into the types of MAC addresses, so there are going to be three types of MAC addresses. One is a unicast MAC address, another one is a multicast MAC address, and third one is a broadcast MAC address. So, obviously, yes, we are going to look into all these unicast, multicast and broadcast MAC addresses in this lecture. But before going into the types of MAC addresses, let us try to understand this address format. As I have told you that it could be a 48-bit or it could be a 64-bit MAC address. Let us try to understand this 48-bit MAC address. So, it is represented as a string of 6 octets, and each octet here is separated by a colon. So, if you can see, the format here is colon, and the SS colon, SS. So, the first half, that means the 24 bits of the MAC address contains the ID number of the adapter manufacturer. So, whosoever is the adapter manufacturer, it could be Dell, it could be HP, it could be Intel. So, one who is we can say manufacturing that machine or manufacturing the adapter, to be specific. And these IDs are regulated by an internet standard organization, and these cannot be changed by a company. So, these are fixed for the companies or the fixed for the manufacturers. Moving on to the second half of 24 bits, which is here denoted by SS colon SS colon SS. This portion of MAC address represents the serial number assigned to the adapter by the manufacturer. So, one part is the identification of the manufacturer itself, another one is the serial number, the second part is the serial number which is assigned to the adapter by the manufacturer. So, here let us say we have kind of 6 octets. So, starting from 1 to 6. So, first octet, second, third, fourth, fifth and sixth. So, first 3 octets are basically organizationally unique identifier, and here is a short form for this, which is OUI, and the rest 3 octets, as I have told you, are network interface controller, which are kind of we can say NIC specific, and within your OUI you are going to get that whether this is going to be a unicast one, or whether this is going to be a kind of multicast address or something of that sort. That, yes, of course we are going to look into that. So, here in OUI, which is organizationally unique identifier, there are kind of pairs starting from B7, B6 till B0. So, this B0 is going to be kind of a significant representation, in which 0 represents for unicast and 1 represents for multicast, while the B1, which is the we can say the bit 1 is globally unique, which is OUI enforced, and if it is 1, then it will be locally administered. So, if it is 0, it is kind of globally unique, if it is 1, it will be locally administered. So, when we look into the types of MAC addresses, which are unicast, multicast and broadcast, we will be looking into this format as well. So, basically as of now we can say, so 6 octets, first 3 octets for OUI, and the next 3 octets are NIC specific. Now, MAC addresses basically having 12 digit hexadecimal number, which is you can say 48 bits in length, or a 6 byte binary number. For example, let us take a network adapter with the MAC address 00-A0-C9-14-C8-29. So, here the OUI, which is organizational unique identifier of the manufacturer of this particular router, is the first 3 octets, which are 00, A0, C9, and this represents Intel corporation, and the rightmost 6 digit represents the network interface controller. So, as I have told you that first one first 3 octets are fixed for the manufacturer. OUI of some of the well known manufacturers, as I have told you, is Intel. It is for 00A0C9 is for Intel corporation, 00-14-22 is for Dell, 0004DC is for Nortel, 3C:5A:B4 is for Google. So, all the kind of well known manufacturers have their separate OUIs. Now, as you all are aware that MAC address is actually a unique identifier allotted to NIC. It is used as a network address for the data transmission within a network segment. It could be a network segment having an kind of Ethernet connection, or it could be a network segment having Wi-Fi, or it could be Bluetooth. Now, when we look into the layers of the sub layers of data link layer, which is DLL, it is, we can say, one of the lowest layers of the OSI, or we can say the second lowest layer. Now, it is divided into 2 sub layers. One is LLC, logical link control sub layer, and another one is MAC sub layer, which is medium access control the MAC sublayer. So, either it is LLC sublayer or the MAC sublayer. So, the MAC sublayer again, it is kind of one of the sublayers of the data link layer of OSI model for data transmission. Let us look into the specific functions of the MAC layer. So, this MAC sublayer provides an abstraction to the physical layer, abstraction of the physical layer to the LLC, which is logical link control, and upper layers of the OSI network. Also, it is responsible for encapsulating frames so that they are suitable for transmission via physical medium. So, that encapsulation has to be done by MAC sublayer. It also resolves the addressing of source station as well as the destination station or group of destination stations. So, this is kind of we can say this function of MAC layer is related to its structure. That means this MAC layer is looking into the MAC addresses. So, on the basis of those MAC addresses, it resolves the addressing of source stations as well as the destination addresses, destination station. That means the MAC sublayer of both the sites, senders and receivers sites, is going to look into the address of the source station on the sender side and going to look into the address of the destination station on the receiver side, or it could be a group of destination station depending upon whether your address is unicast or it is multicast or it is broadcast. So, it can be a single destination or it can be a group of destination. So, in order to kind of handle these addresses, it performs multiple address resolution when more than one data frame is to be transmitted, and it also determines the channel access method for the transmission, that which which channel access method is going to be most appropriate. Apart from these functions, it also performs collision resolution and initiating retransmission in case of collision. So, if there is the collision, then it is going to kind of initiate the retransmission, but yes, we are yet to look into the collision resolution and its kind of related protocols and mechanisms, which definitely we will be covering in our upcoming lectures. Also, this MAC sublayers generates the frame check sequences and thus contributes to the protection against transmission error. So, this kind of we can say error handling mechanism is also one of the functions of this MAC sublayer, because this is the layer who is going to generate the frame check sequences in order to look into what kind of transmission errors have kind of occurred. So, another portion of this data link layer apart from this MAC sublayer is LLC, which is logical link control. Now, let us look into the functions of LLC. So, the primary function of LLC is to multiplex the protocols over the MAC layer while transmitting, and likewise to demultiplex the protocols while receiving. So, at the sender's end, this is going to multiplex the protocols over the MAC layer, and at the receiver's end, while it is the data is being received, the function of LLC is also to demultiplex the protocols while receiving the data. So, we can say that LLC provides hop to hop flow and error control. Definitely yes, error control is also there, and it allows multi-point communication over the computer network. Frame sequence numbers are also assigned by LLC, although the whole address is kind of we can say kind of managed by your MAC, but the frame sequence are being assigned by the LLC, and on the basis of these frame sequences only your selective repeat or your go back and protocols are working, and then they are able to identify that which all frames are needed to be retransmitted. And if if it is kind of an acknowledged service, as we have looked into the go back and selective repeat, it also tracks the acknowledgement. So, it is the LLC who is going to track the acknowledgement. Moving further, we have just looked into the names of MAC, names of the types of MAC addresses. They were unicast, multicast and broadcast. So, let us look into detail that how are we going to identify that which address is a unicast address, or it is a multicast, or it is a broadcast address. So, unicast addressed, or we can say a unicast addressed frame, is only sent out to the interface leading to a specific network interface card, or NIC we can say. So, when we say unicast, that means it is kind of referred for one particular or we can say a specific NIC. So, if the least significant bit of the first octet of an address is set to 0, that means the frame is meant to reach only one receiving NIC. So, in the format we have looked into the first octet and the second octet of the MAC address. So, the least significant bit of the first octet of an address is set to 0. The frame is meant to reach only one receiving NIC, and in this case the MAC address of the source machine is always unicast. Looking into the second possibility of multicast, the multicast address allows the source to send a frame to a group of devices, because the term is multicast, that means it is being casted or it is being sent to multiple nodes. So, in layer 2 multicast addressed, the least significant bit of the first octet of an address is set to 1. For unicast it was 2, but for multicast the least significant bit LSB of the first octet of an address is set to 1, and IEEE standard or IEEE has allocated the address block 0180C2 and then the next kind of we can say octet as designated. So, it has allocated the address block 0180C2 000000 0180C2 FF for the group addresses to be used by the standard protocol. So, IEEE standard organizations has allocated the different address block for the group addresses also, and these are to be used by the standard protocols. So, we have looked into the type of MAC addresses, unicast and multicast. Moving on to the broadcast. So, similar to the network layer, broadcast is also possible on the underlying layer, data link layer. So, the broadcast is also available, or the broadcasting facility is also available on the network layer, and it is also available on the data link layer. Ethernet frames with ones in all bits of the destination address are referred to as the broadcast address. So, which addresses I am referring to? So, I am referring to FF FF and the similar the second trio also FF FF. These frames are destined with MAC addresses which are in the form of ones in all bits of the destination, will reach every computer belonging to that particular LAN segment. So, in this way your MAC address or the type of MAC address is going to we can say decide that whether it is a unicast address, or it is a multicast one, or it is a broadcast one. Now, here we have looked into the detail of these MAC addresses carefully, but we also we have also heard about the IP addresses. Now, let us try to explore that what is the difference between the two, or we can say what is the reason that we are having both the IP addresses and the MAC addresses, and how this is going to how these two are going to be used. So, the reason for having both IP and the MAC addresses actually lies in the way your internet is functioning, or more specifically we can say how the structure, how this OSI model is being structured. As you all are aware that this model is a conceptual framework that describes the communication, or that describes that how this data is going to be sent and how this data is going to be received over a particular layer. So, 7 layers are being, or the model is being divided into 7 layers, and each layer is having its own different function. Now, your layer 3 uses the IP addresses and is responsible for the packet delivery end to end. Your layer 2 uses MAC addresses and is responsible for the packet delivery from hop to hop. Now, let us try to understand these terms hop to hop and end to end. So, we have, let us say, one sender and receiver which are designated as S and R, and within these we have 3 other machines. So, from S your data is going to 1, from 1 it is going to 2, from 2 it is going to 3, and from 3 it is going to your receiver R. So, when we say hop to hop, so from sender to 1, 1 to 2, 2 to 3, and from 3 to receiver it is hop to hop. When we say from end to end, so it is from sender to receiver. So, on the basis of this background, I repeat, layer 2 uses MAC addresses and is responsible for the packet delivery from hop to hop, while layer 3 uses IP addresses and is responsible for packet delivery from end to end. Now, your layer 2 uses MAC addresses which are kind of assigned to NIC, and they are unique. The primary function of the MAC addresses is to manage how the data is transported from one network node to another network node in a direct or physical basis. So, that is why this is more commonly known as a hop to hop delivery. But if we talk about the the next one, which is the layer 3, it is going to use the IP addresses, internet protocol addresses. These IP addresses are used to identify devices on a network and to route the traffic between different networks, and these IP addresses ensures that the data which is from the original source reaches its final destination, and hence it is also known as end to end delivery. So, when a computer sends the data, let us try to see what kind of procedure is being followed in between. So, when a computer sends the data, it first wraps it in an IP address which includes the source and the destination IP addresses, obviously both are required. The IP header along with the data is then encapsulated in a MAC header which includes the source and the destination MAC addresses for the current hop in the path. As the data moves from one router to the next, the MAC addresses header is stripped off while it is going to be received at another hop, and a new one is generated for the next hop, because it is now the MAC address is going to change, not the IP address obviously. However, the IP address which was generated by the original computers remains intact until it reaches the final destination, and this process is we can say explains that how these IP header manages the end to end delivery, while the MAC headers handle the hop to hop delivery, because MAC address header is stripped off at each and every hop and a new one is generated for the new upcoming hop. So, both IP and MAC addresses are essential for the functioning of the internet, while your MAC address facilitates the direct physical transfer of data between the various nodes of a network. IP addresses or IP address ensures that the data reaches its final destination. And hence why we can say that MAC address is basically for your hop to hop delivery, while your IP address is for end to end delivery. Let me summarize this lecture. In this lecture, we have looked into one of the very important concept of data link layer, which is about the MAC address. We have looked into how these MAC addresses are looking, or basically what is the format. We try to understand the address format of these MAC addresses in terms of we can say different octets, and then we have seen the relationship of these octets and the bits which they are kind of having with in relation with the unicast, multicast and the broadcast address. We also understood the concept of OUI, which is organizational unique identifier, which is also an important concept of MAC address. Then we quickly looked into the functionality of the MAC layer and also the functionality of LLC, which both of them are the sublayers of data link layer. Then we looked into the different types of MAC addresses, unicast, multicast and broadcast, and we also understood that what is the reason behind having both IP and MAC addresses, and what is the importance of these both type of addresses. So, IP addresses for end to end delivery, while MAC address ensures the hop to hop delivery. And here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.